Hi everyone and welcome to this presentation. Today's talk is about a case study focusing on OWASP ASVS level 3. Basically the project was about source code review and how was the project conducted based on the OWASP framework. First of all, just to introduce myself. I've studied informatics and have master's degree in information security. I'm currently working for 12sec as a security consultant and penetration tester. Mostly doing mobile and web application security projects and many other kind of stuff. Yeah, Tax was supposed to be here today as well, I believe, but he prefers Dubai probably and some business there. So yeah, I was left to deliver this presentation to both of us. So let's quickly see what the project is about. Let's go through a short intro. What we're doing today, is to share some lessons learned and present our experience from a source code review project that was implemented last year. It was based on the level 3 ASVS framework version 2 of 2014. Basically, what it was about a Java project focusing on some European Union service web system with the technology stack here: Java 1.6, JSP, Struts 1.2, EJB 2.1, and JVA 1.0. The final scope was more than 250,000 lines of code. Yeah, not the biggest project in the world, but still enough to keep you busy for some months. So, what was about the project challenges, the particular challenges that we were facing around the project? The first of all, at least to me, it was the complex EU business supported by the system. As you probably know, if you have some experience with European Union systems, there are particular regulations implemented throughout the system. So, for a non-related user like us, it's really hard and really difficult to monitor that and track all the business processes implemented across the system. There was also a quite outdated technology stack, as you can see from the previous bullet. Probably not the oldest technologies, but it's still a lot to expect, many findings, and focus our attention to some depreciated API. Also, another challenge across the project was that the project was developed like 10 years ago without any security requirements, any guidelines, or without any review of the application and the architecture part. So I think this is all enough to expect a lot of work to be conducted and to expect many findings to be present. So just to give a better posture on what we have seen there. In terms of findings, there were about 34 categories as identified in the final report, of which 6 were high, meaning that the score was CVSS 7 and more, and greater. So if you extrapolate that to the CWE 25, there were 20 categories of CWE present on the project, and 5% were not identified there. And also, if you calculate the ASVS controls that were successfully passed or failed, the majority of the controls were failed, so we can see that there are a lot of requirements not met and many controls not in place. So In this part, we will go through the methodology applied and see, and later on this talk, we will break down and see all static and manual code review, static automated and static manual code review was applied across the project. So the general process that was followed was about security requirements at first hand in order to define what the level should be and agree on the framework to be reviewed. In the next step, there was a utilization of the threat model of the application that was developed in order to utilize DFDs and put them into the process for our review. There was also automated, as we said, automated and manual source code review, meaning that there were also tools, commercial tools available for that, and also manual review through the development environment, and also the evaluation according to CVSS version 2 for score rating on the findings assessed. Quickly here, a crash course on the ASVS. Probably most of you will have heard of that, and stands for the abbreviation stands for Application Security Verification Standard. It is a framework developed by OWASP in order to facilitate the whole process on security verification and provide guidelines in order to review modern applications in terms of security. What the ASVS does, it provides a set of security controls that will be utilized as the security requirements, generic security requirements across the project. So, in this manner, security and development teams are able to provide an important level of security and confidence for commonly known problems that we usually have to face on web applications today. Mostly, ASVS focusing on the following categories. Most of them are also related to the categories presented in the OWASP testing guide. There are particular controls across these categories in order to elaborate in a security level and apply requirements on different levels and different security requirements on that. Lately, there was an update on the ASVS of OWASP on October 2015. There was the latest version applied the last two categories on web services and configuration. Also added to the previous categories of the previous framework. So in terms of levels, we can say that the framework provides 3 levels of acceptance. The first level is the minimum level required for applications to be assessed. Usually, level 1 integrates controls and requirements that will be able to be assessed on an automated tool assessment. And usually, level 1 reflects controls to be in place, focusing on attacks of low effort, and it's like more an opportunistic level of security provided. The level 2 is a more standard level. It provides an adequate level of defense across the system. What it's actually about, it's about business-to-business applications with some sensitive functionality inside. And also the controls that are in place They're actually focusing on some more skillful attacks and techniques, and also some highly popular tools on the security picture today. As for the level 3 that was in the scope of this project, level 3 provides a very detailed level of verification. There are some very pervasive and very detailed security controls that should be checked and should be verified. Usually this framework, this level of the framework applies to some mission critical systems and such as military applications, and in general level 3 is applied to anywhere where the failure of the system will be of major cost. So if you really want to go through a security assessment and have a very detailed view of the system in scope, you should prefer level 3 for that. As we said, there is a very exhaustive list of requirements in order to be met. So penetration testing is not enough in order to assess all the requirements of the framework in that level. And as a result, the consultant should also consider the design, the architecture, the threat model, and the security configuration as well, and also conduct many workshops and interviews and audits with the development team, just to make sure that everything is clarified and all the controls are assessed properly. In this manner, the threat model documentation is also under consideration, and in order to fulfill all the requirements, the source code review, detailed source code review should take place for that. Yeah. What was the role exactly of threat model? It was about identifying crucial information for the SCR process, the source code review process. When we are interested in the threat model document, it's about documented parts of the application, such as the architecture, the system decomposition, and different components and different subsystems. Through the threat model, there are also identified threats and assets, and there are defined the trust level across the system per system process, per business process actually. And there are also the data flow diagrams that depict information in the manner of entry points and data flow across the system from the user input back to the database. There are also, based on the OWASP scheme for marking data flow diagrams, there are also trust boundaries that define across the project and across the data flow. So we are able to know from which source per component the data is accepted or trusted. At the first part of the static code analysis, there were some tools, some commercial tools utilized for that. Some different tools were applied, and as you probably know, the source code review finds an added value to the commercial tools or the open source tools applied across the system. So what we can gain from this part of the process is to have a big picture, get the big picture of the security posture, and based on the report of the code analysis tool, we can know more or less what we should expect for the manual process to be continued later. Based on the results that we have received from the tools,
we can see that automation is very good to present some, to give a good sum up on massive instances of easy and some low-hanging fruits, as I said, which is reflected to low and medium risk findings, such as things like that regarding XML schemes, XML weak schemes, working credential implementations, or hard-coded credential, depreciated API, and this part of the process is very well facilitated by the automation tools. And as for the project itself, in an estimation of the total findings of the project, we can say that the tool contributed 30% of the total findings. However, none of them were of high severity and high risk. Some drawbacks of the tools throughout the process. As we said, there were no high severity categories identified. Also, we knew that business logic vulnerabilities were not about to be presented or to be delivered by the tool to us. Also, this is an important part of the process of the use of the automated tools. As you probably know, most of them provide a huge amount of false positives. So, in terms of the effort estimation, anybody could accept or could expect the 10% of extra effort to spend time just to make sure that everything will be delivered that will not be false positive, and automation findings will be verified. Another drawback that we identified across this project was that the automation report actually misled our focus from specifically vulnerable parts of the system. As we said, there were several findings reported. However, due to the fact that no high risk issues were reported, we lost our focus from the serious vulnerabilities that were identified later during the manual review. Some cases about what was missed by the tools. So, for example, in the first case, you see some output delivered without output escape in some JSPs across the project. Heavy use of string concatenation in the second case that was delivered later as an SQL injection. And also some password remind functionality that was delivered previous password plain text to the user. Of course, not accepted by ASVS level 3 requirements. So, for the last part of the process, here we describe what we have done for the manual review and how the process was followed in order to provide even better results than the automation and integrate all the findings for the project delivery. Yeah, what it looks like to go through a static manual review of the code in the level 3. It more or less like a mosaic investigation wall, trying to connect facts, things, parameters, whatever you say. If you try to do that in a manual perspective, you will be able to, in contrast to the tool, you will be able to utilize architectural information, specific details that, of course, you know when the tool does not. And also, in this manner, there are also required workshops, audits, interviews, and heavy assistance and collaboration with the development team of the project in order to verify findings and clarify potential issues that are presented in different phases of the project. As for the source code review execution, there is a preparatory stage that we have considered. As we said earlier, there is a really complex regulation and really complex rules applied in the business of the system. So the first part is to perform the very first part is to perform a study on the business concepts applied on the system. So make sure that we clearly understand everything that we see and later interpret it to code and make our effort more efficient in terms of assessing the code across the system. There is also a second part of that, focusing on the documentation of the project. As of special focus on that is the use case diagrams and the class and components diagrams. So we need to study all this in order to make sure that we follow all the use cases provided by the user, have a good view of the classes, all the key classes designed by the system, and take this two steps as an introduction to go through across the project in a more detailed manner. Also, it's a good practice to go through the coding standards and practices applied. This is more about discussing coding practices and approaches applied by the development team, and also consider data sensitivity mapping, if any, as well as the security relevant events. Data sensitivity and security relevant events are quite important for the level 3, since many controls of the framework rely on this kind of mapping and this kind of identification. Of course, before starting doing anything actually, it is very important to go through the language-specific guidelines and also investigate the functionality of the technology stack involved in the project. So, if you go through the rest of the project, it is a very good choice for first step to collect all the necessary third-party libraries and dependencies of the project and perform some investigation to see how it stands from an API perspective. So to deliver anything that is a third-party vulnerability beforehand. Also, as we said, it's also a good practice to utilize the static analysis tools if they are available across the project. This is good to be done in the first stages. So, as we said, to get a security posture of the application, and then we can start to utilize the data flow diagrams as presented in the threat model in order to get ready for the code itself and identify the entry points where the auditors should start the review. Finally, since many projects like that are quite complex in terms of business and functionality, it's a good practice to prioritize the DFDs in scope and prioritize according to complexity, just to make sure that you have an incremental entrance in the project, and you will be able to start with some more feasible and more simple cases to review. This is also important because you will be probably working with different teams of development. For example, some teams will do the front end, some other team will be responsible for the back end. So if your team works in more than one person, two two people, you can go and focus per functionality in order to assign particular auditors to particular development teams for further collaboration. In the last part of in the actual source code analysis, you can utilize the development environment. So in this manner, you can someone is able to using the navigation hierarchy and identify caller and callee relationships just to make sure that the flow is as proper, and also identify key classes. Perform an exhaustive inspection of the imports and or the include, depends on the kind of code that you have to review. So this is an important part of the process. If you're not sure about the dead code applied and the dead and the active code applied inside the project. Also, there could be different parameters and different relationships between file names can be utilized. For example, what we have identified is that every JSP focusing on anything results JSP, we're including the same XSS parameters. So since we have seen that like 2 or 3 times, we were expecting to see that everywhere in the result JSP. And so did happen. There were also search engine and regular expression capabilities that could be also utilized for the previously identified findings across the project. Another approach also for managing the ASVS requirements as well was to parse key files of the technology stack, for example, the struts config XML or the web XML, in order to perform custom scripting for managing the ASVS requirements in scope and give a better answer for yourself through scripting and also manual verification. For the post-source code review process, there are also final round workshops with the development team just to make sure that everything is covered and every issue is verified. And anything that is not verified beforehand and does not meet the ASVS requirement, this is an issue for the report, and this is also should be documented in the level 3. It's also a good practice to maintain the security picture of the system by continuously monitoring the upcoming releases in terms of dips. The files that usually implement bug fixing and further release requirements. Also, what was identified in this part of the process, it is that previously identified vulnerabilities of the major code base in scope were still propagating in the next releases through the code reviews of the development team. So to conclude on that, we can say that the ASVS level 3 rules are a good indicator in order to have a good security picture of the system. This should be done through the source code review as non-penetration testing activities are required, and most of the controls of the level 3 are not penetration testing artifacts. Also, the security documentation can provide really useful information for the security review. This is mostly related to the data flow diagrams depicted on the threat model. Another good conclusion of that project was that it is a good practice to leverage short deliveries in order to verify issues. Get closer with the development team in order to perform scoring rate and support your learning curve across the system, since you will be learning even more the system throughout the project. And of course that security is better and easier when integrated in a built-in manner. This is mostly related to the level 3 of ASVS, because Since the level 3 requires very pervasive and very detailed controls, most of the controls failed across this project will be very difficult to be implemented, or some of them even impossible, just because they were not considered beforehand during the design and requirements phase of the development. So this is it.